Here, we choose to think about time, specifically how long it takes to complete a full period of a sine wave moving counterclockwise, increasing the phase and accumulating 30 degrees for each point. The timer, currently circled in red, increments when you hit the first yellow dot at 0 degrees. When we have accumulated full 2 pi or 360 degrees, we will have completed a period of the sine wave. The faster we can do it, the shorter the period and the higher the frequency. Since frequency is 1 over the period, I have been clicking on the points counterclockwise around the circle every second, as you can see from the timer. When we hit the end point, the frequency will be close to 0.083 Hertz, or 1 over 12 seconds, since there are 12 dots and each one took about 1 second. Notice the purple circle on the graph around time of 12 seconds. This is the period of the sine wave we created, and the sine wave repeats at this rate, assuming you would have kept clicking the same points at the same rate. There may have been some small imprecision in time due to your web browser. I am doing things that you can do on your own when this demo is complete. I recommend listening to all of the segments in the demo before trying it yourself. We just finished segment 1. Hit play and let's do segment 2. The first time we sampled the unit circle, we collected 30 degrees every time we hit a yellow dot, and it took 12 samples or 12 dots to get the full 360 degrees. This time, we will skip every other dot, collecting 60 degrees on every point, so we only have to hit half as many points to get all the way around the circle to a full period of 360 degrees. Thus, at 1 second per sample, we will get a full period twice as fast as before. Now, the period of the sine wave is about 6 seconds, and the frequency is 1 over 6, or about 0.16 Hertz. The purple circle on the graph is now at 6 seconds, whereas before it was at 12 seconds. Notice from the graph how this faster sine wave is twice as squished as before, because now we have 2 complete cycles, or periods, in 12 seconds, whereas before it was only 1 cycle in that time. If you just completed segment 1, the newest graph is in dark blue and the older graphs are in light blue. I recommend listening to the segment 3 and 4 of this demo before playing with all this yourself to understand it more deeply. In segment 1, we accumulated phase around this unit circle at 30 degrees per sample. In segment 2, we accumulated 60 degrees per sample, and now we will do 90 degrees per sample. It will only take us 4 points to make it all the way around to a full period of 360 degrees, since it took us about 4 seconds to complete a full 360 degrees. The period will be about 0.25 Hertz, or 3 times faster than the first one we went around the circle. If you have run each demo segment back to back, you will see this in the plots to the right. The newest, darkest plot has 3 periods within the time it took for the first pale blue plot to make 1 period. The newest frequency is 3 times higher than the first one we did. I recommend listening to the final segment 4 to see our fastest frequency and learn what you can do on your own. In our final segment, we will collect samples every 120 degrees. Clicking on the 0 dot starts the timer, and, as before, we click dots once per second. It will now take us only about 3 seconds to accumulate a full period of 360 degrees. The very first period we created at 30 degrees per point is gone now, but if you ran these demo segments back to back, we can see that we are twice as fast as the pale blue curve from segment 2 when we clicked 60 degrees per sample. If you want to understand why it's okay to click fewer points to sample the curve, Click on the Advanced pop-up in the upper left of this page. Now you are on your own to do all the things I have done in this demo and whatever else you like. All you have to do is click the 0 phase point labeled Start Here to start the timer, and then click on More Points, counterclockwise around the circle, and end at 360 degrees to stop the timer and see your results. I hope you are faster than my 1-second click rate for dots. If you are on a mobile device, you may have to expand the yellow dot size to be able to hit it with your finger.